need to introduce them to you. We have Dr. Isabella Bay. She's one of the leading AI thinkers in China, building the brain behind humanoid intelligence, not how robots look, but how they think and act. She is the founder of ELO Technology and InfiForce Robotics. Please welcome Isabella.
Before starting InfiForce, I was vice president at Alibaba, and I have the experience of building unicorn company. This year, I'm also very honored to be named in Fortune's MPW, Most Powerful Woman. But at heart, I'm a tech believer. We are a team of scientists based in Hangzhou, China. Work on one big dream, giving AI a physical body. We are building the brain for robots, so they can truly help people in real life. At InfiForce, our strategy is simple: one brain, multiple bodies. Thank you very much.
Then we have Dr. Andrea Thomas. She is the founder of Diligent Robotics and puts robots where it actually matters, in hospitals. To nurses, to patients, and then also to real human workflows. Their robot, Maxi, is already deployed in 25 hospitals and has completed over 1.25 million real-world tasks. Please welcome here on stage, Andrea.
Yeah, thanks. I'm happy to be here. Excited to talk about our Moxie robots and not quite human robots altogether.
Then we have Modar Alawi. He operates at the intersection of technology and capital. He is the founder and general partner at ALM Ventures and chair of the Humanoids Summit, seeing early which robotics visions really matter. Please welcome Modar. And we have David Vega. He's the founder of Neura Robotics, building what many believe is becoming the operating system of physical AI, the Neuraverse. It's like Apple's iOS, connecting robots, data, all physical AI together in one learning system. Please welcome David.
Thanks for having me.
This panel is called Not Quite Human, and I want to see how each of them are interpreting it in a different way. Not quite human. Isabella, when you hear not quite human from your perspective, it could mean intelligence without human biology. Machines don't need to imitate humans to be intelligent. Human intelligence is not about the body, it's about cognition. So where does intelligence start for you?
I think for me, intelligence does not need a biologic body. It begins with cognition. At InfiForce, we build a digital brain to create this cognition. We call it HyperVOA. It stands for vision, language, and action. It combines these three to create a loop: see, think, act. And deeper inside, we use a crossword model to help it understand the world. Such a brain can be applied to multiple bodies.
Okay. And David, from your perspective, not quite human could mean intelligence as a system, as a scalable system, not an individual. Human-like behavior is irrelevant if intelligence doesn't scale. What actually turns intelligence into something that is scalable for you?
So I think here I would love to bring up a little bit of a challenge, or being like a human means actually having possibilities or interacting with this physical world in a very natural way, also in in a very, let's say, interactive way. And this is, I think, also the biggest complexity we have right now in robotics and artificial intelligence. Having this different, let's say, two-layer architecture on the physical body, where you basically have reactive, like a nerve system and memory affecting the muscles, and actually the brain, which is making the big decisions, plus a combination maybe into a cloud to get a broader knowledge. And this is something we want to solve, and we are going to solve. And it's also the most exciting piece on robotics and artificial intelligence today.
Yeah, very interesting. Andrea, for you, not quite human might mean human enough to be trusted, but clearly not human, because over-humanized robots can create discomfort. And I think the clarity of the role of a robot matters here. You put robots into hospitals and into real lives to people. What surprised you most when it entered people's everyday lives?
Yeah, no, we think a lot about designing the robots to be a teammate for the clinical teams that the robots are joining, and so some of the things that come into play, it's really important to be adhering to particular social norms and staying on the right side of the hallway as you're navigating. It was surprising to us how, so to bring one thing, lots of things are surprising when you put robots into the real world, and it's not your simulator, and it's not like all of the things that you thought were going to happen. You see all of the edge cases of the real world, and particularly people and how weird they can be around robots, and how robots have to be able to adapt. But we found that when you're adding robots to an environment that they're joining a team and they're with the same kind of people every day, you see people wanting to help the robots. And so one of the specific examples, our robots use the elevators by pushing the buttons and doing mobile manipulation actions dynamically. But a lot of times we can now just ask people, if there's a person in the elevator, you say, hey, could you push the second floor for me? And so that was learning that we took from the real world, and saw that people are more than happy to help.
Wow, they're pretty much integrated. That sounds interesting. Wow, surprising. And Mona, for you, not quite human could be a necessary correction to the hype. Human-like narratives sell demos, but not businesses. From your market perspective, what is currently overhyped and what is underestimated in the humanoid robots world?
I guess I'll start with what's underestimated, which is the complexity, and kudos to everybody that's really building these human machines or human-like machines. They're very complex. They try to imitate humans in human environments, in environments that have been built for humans, with doorknobs and chairs and counter height items and whatnot. And so we're trying to almost create a machine to be retrofitted into a human-like environment. So not just that, but with all the complexities of the sensors, the sensor fusion, the computes, the battery, the scarcity of the resources in one single body. So that's really what's being underestimated in my opinion. And of course, we're all talking about embodied AI because of this new wave of Gen AI, and Gen AI is still considered, for the most part, supervised learning, which requires a ton of data, and real-world data, not just simulation. So that's, I can go on and on with all the complexities and all the things that are potentially being underestimated, but the hype is really in what we see publicly, especially on digital platforms. It's the pixel perfect videos, it's the perfectly edited scenes which do not necessarily translate into real world environments. We host the humanoid summits not only for speakers and biggest brains in the world to come and talk about what they're working on, but also to have demos. The demos at the expo show exactly where the progress is, and so there's a huge discrepancy generally between what videos are showing or what websites are showing and what the actual demos in a real world are doing. Even if they are geofenced or even if they are controlled demos, there are still some challenges there. And so kudos to everybody that's building humanoids, but also demonstrating them in public environments.
What is your next sound, by the way?
All Our next summit is in Tokyo at the end of May 28th and 29th. It's going to be our fourth one. So we hosted 3 so far. The first one was in Silicon Valley. The second one was in London at the end of May last year. The third one, we had it just about a month ago. It was phenomenal. We missed you there. And so the next
We're
one
ready
is
to
going to
come.
be, you should definitely come at least to the Silicon Valley one, because it is becoming a staple of where humanoids are being talked about, but also demonstrated. So Tokyo is a hotbed for automation. There's a phenomenal obsession with humanoids, and it's cultural more so than anything. And so we're pretty excited to be going to Tokyo next time.
All right, thank you for the invite. So rather than asking more questions, let's play a game. I'd like to test a few hypotheses, and I want you to respond with agree, partly agree, or disagree, and a short reason. Okay, are you ready?
Let's do it.
Ready, cool. Robotics is not a short-term trend. It is a structural necessity. Who wants to start?
Agree.
We can make it easy round, huh?
Agree.
I strongly agree. I think in our industry, in particular healthcare, we've seen the labor dynamics. It's just not possible to continue with the current.
I can imagine your industry, yeah. And you?
I totally agree. The world is aging. Labor force is shrinking. Robots are the solution for the future workforce.
Yes, okay. That was easy. In robotics, intelligence matters more than humanoid appearance. Someone else needs to start.
Totally agree. Obviously, I mean, you can think of like a human body without a brain and what that can do, regardless of how many sensors it has and what environments it's in. So obviously, intelligence is the 90% weight of the complexity even for building humanoids today.
Okay.
I'll give another agree, and I think it's even more like from the other side, from a human-robot interaction perspective. If you have a humanoid form factor without human-level intelligence, there's a dissonance that doesn't work for people.
Okay.
Agree. A beautiful body without a brain is just a puppet. So we can focus on the brain first. If the brain is smart, the form can change.
Yeah. And David?
I also agree, and I think my company represents exactly that. All form factors matters in the future, and I think it's more about the brain behind and how intelligent it is, and how can we transform that to different form factors. I think is key for the future of automation.
So I think like having a quiet human matters too, right? Also in hospitals.
Yeah, I think having a form factor that is safe and effective today, and then you can build on top of that. Our robot is a mobile base with storage capacity, and then a more kind of human-like or humanoid arm and torso and head on the top half. That could evolve in the future. I think it's more about how the complexity matches the workflow.
Yeah. So data, not hardware, is the biggest bottleneck in physical AI. Who wants to start? Isabel.
Totally agree. Hardware is ready, but high quality physical data is lag and expensive. That's why we need a real scenario deployment to start the data flywheel.
Okay. Mona or David? Yeah.
I actually disagree. I think it's like half-half. Yes, to create actually the right data, you also need to have a right sensorization package on your robot, and you have to, let's say, design a robot the way that you have actually something which can be interactive and send the right data to actually get the right data. And I think this is the challenge we have today. Even your gaining data, maybe out of industrial robots, will not help you to make this robot intelligent itself. It's all about having the right sensorization package where you can actually, and in the right timestamp, so you can actually start training on it. So, and this is, I think.
Would you agree, Mona?
I do agree. Data is the biggest bottleneck. The reason why we're talking about humanoids or robots today, as opposed to 3, 4, 5 years ago, is because of AI, and so AI requires a lot of data. I can also kind of draw the example of the early days of autonomous vehicles, and so the data is important. I touched earlier on the importance of why today we're talking about AI and why AI is still supervised, because it does require a lot of data, a lot of annotated data or manual data, or not so much self-supervised or weakly supervised or unsupervised for that matter. But I also agree with David, because if you want a robot to do tasks that can either help humans or replace humans, you do want to at the very least have the 5 human senses provided to the robots, and so the sensors have to be there. The data, the fidelity of the data has to be collected in a very accurate way. It has to be varied enough to cover every corner case or edge case. It has to be large enough for it to be able to train models. And it has to be from real-world environments as opposed to simulations alone.
And Andrea?
Yeah, I would strongly agree that data is a big part of the problem. I think we focus a lot on creating the data flywheel in the environment that we're operating. So you know, it's got the sensor package to solve all of the edge cases for an indoor commercial environment like a hospital. And as you are out having experiences, you can feed in those edge cases to the AI models as you go. I think an interesting data augmentation that we're going to see take off a lot is how you can take real world data like that to then build synthetic data on top of it. So I think we're going to see a lot happening there.
Okay. Next, general purpose humanoid robots are much more further away than many people think.
Absolutely correct, yes. I mean, if you talk about general, that means you can't do anything. It's pretty much, general is a very broad term.
Yeah.
Not even humans can do general work, right? So it's a decade plus endeavor, in my opinion, and it's going to be an ever evolving problem, because what's general for some countries or some cultures is not for others, and what's general for certain environments is not for others. General enough for manufacturing, that's probably pretty good. General enough for hospitals, for warehouses, for entertainment, for certain environments that are, that have enough degrees of freedom, but not unlimited degrees of freedom. But that's what makes everything exciting, is really the learning curve and the evolution of how tech moves at a very rapid pace.
And maybe David, is general something we should strive for?
So I think yes, why not? But the way to get there, I think, is relevant. So how do we get there? And I think if we just try to make an end-to-end model for everything, basically a general, then you're right, it will take decades. But if you do it like we do, short marketing, advertising for Neuroverse, actually the platform, I think it's a little bit like in a smartphone business. So if we go and just try to solve everything ourselves, it will take decades. It will never be there, because even how big our company is, you will never be the expert in everything. The difference from Neura to most of others, until now I see all others, is that we are actually building platform-ready hardware and a platform where people can actually connect themselves to and train the robot themselves. So, and I think this is a solution to get faster there, to solve all world problems, because I think everyone will have the pressure to solve it, because the competition worldwide is right now pretty strong. So, and I think this will go much faster than people expect on this planet. That I think the next 3-4 years will be breakthroughs. We will not, I don't think we can imagine what will happen because of the platform thinking we have in our opinion.
Okay, Andrea or Bella?
Okay. This question, I should partly agree. The brain is evolving fast with the hyper-VOA, but the body needs time to be reliable and cheap. We will see humans first. We general humanoids later, I think.
Okay.
I'm going to agree. I think that it's further away than people think. But what is exciting in the near term, I think, is that we'll start to see if we take a definition of general purpose to mean a robot with a single form factor can be doing many different tasks in a particular setting. I think that will be a kind of general purpose that will feel like demonstrably different than the kind of robots that have been deployed before.
Okay. Now, quick answers, please. The home is not the right starting point for robots. Industry and healthcare are.
Say that again.
Yeah. You want to start?
Okay, I think absolutely agree that I think that the semi-structured environment of healthcare and industry, as a couple of examples, it gives you a scope of tasks and things that robots can take on and really provide value that is needed today. So I think that's going to continue to be real deployments in order to solve real problems in an industry. You have to do something well enough and reliably enough that people are willing to use that robot for that task every single day. And so I think we're going to continue to find areas of work that robots can take on, and then we'll expand those use cases as we go.
Anyone, another opinion on that?
So I think industrial use cases are simpler because you don't have to solve everything. You just simply can focus on some use cases, solve them, and you will have a huge impact. So, and that's I think the difference to households. The expectations are super high. The work it will never be good enough. So like I can impress you. Like come and visit us. I will impress you with some robots, bring you some drinks, and serve you. It looks awesome, but as soon as you watch that for 2 weeks, you will actually be annoyed by that because it's way too slow, not really good enough. So, and that's the difference to industrial use cases. So if you are able to press a button, turn a switch, put a part into a machine, and close the door, you're actually solving 60% of all the tasks worldwide. So in industrial space, and this is also, I think, why I expect robots much faster into space than everyone expects.
Any other opinion?
I think this question partly agree. Industry is easier, but home is go for general intelligence. We start with simple things like charging car, but we aim for dynamic and complex things such as home.
Okay. Let's switch gears now to our next game. It's the use case firework. So I want you all to be very short and precise with the use cases, and the use cases should be impactful, of course. And we can start with Andrea, and let's do 2 rounds, okay? So you have 2 use cases each you can mention, and let's be nice and sweet. Andrea.
So I'll give our current use case, which is point-to-point deliveries in hospitals, delivering medications, lab samples, supplies, so that people can focus on patient care.
Great. Woda.
Industrial automation, I see it as a short-term use case. It's just a step up from existing automation that we have. The second one is.
Oh, wait. Second one next round. David.
Take mine away.
You have the chance now.
I think I described already one of the applications, which I think is the first I see, and the other one I think, which we're seeing already. I mean, the most robots, humanoid robots, also deployed right now in the space of serving. They're like bringing someone somewhere, entertaining. And that's what we see mainly right now in China. But I think this will swap more and more also into the Western world. But I think the first, let's say, really useful application will be like pressing buttons, turning switches, taking parts of the machines.
Okay, Bella.
We bring our super brain into real life scenarios. For example, the city. In parking lot, our robot finds your car and charges it. Dark lights, moving cars, the brain handles the chaos perfectly.
Okay, that's also a good one. Andrea? Okay, I'll stick with healthcare and hospitals. More dexterous tasks that I think robots will soon do in hospitals is preparing and cleaning up after surgical procedures.
Yeah, that's a good one. Modar.
I'll group this one into two buckets. There's a lot of overlap, and that's entertainment and home. One leads to the other. Clearly, entertainment is probably the midterm one, and then home later on. Just because of the massive impact these robots potentially, when deployed safely, can have on society as a whole.
So home will follow industry. Okay, David.
So I think what we are right now also focusing on as next right now is assembling. So being able to assemble things with dexterity, like capabilities in fingers and that's hearing, seeing, feeling, and I think there we will also bring a huge impact because this is something today mostly humans can only do, and it's something solving a lot of problems worldwide.
So your robots put one thing to the other place, right? Yeah, that's the thing.
I think that the tough thing is like really putting it into each other and force control and things like that. So there's a little bit more intelligence required and mostly human required because it's not like something you can just program. It's actually autonomous, like reacting on, let's say, different situations. So.
Yeah. Yes. And Bella?
Okay, second, the whole, our humanoid robot, Asteroid, tidies up your room. It thinks math, it understands math, and it cleans up. Okay.
Yeah.
Yeah.
So also cleaning up. Yeah. So let's now do a quick reality check with our audience. So I want you to be the industry, the society, and so on. Questions later. And our panel is the jury. So I want you to show hands. What's your opinion? And we can we will say something to that. So who of you feels more excited than worried about humanoid robots? Okay, a lot of hands. And who feels more worried than excited? Fewer hands. Okay, so they feel excited. What do you think about that? You think it's
awesome?
That's good. That's good. Or should they be more careful? Huh?
Have a good audience.
What do you think?
It's a good representation of really the industry out there. Every major CEO in the world is talking about how excited embodied AI and robotics is, and this is just a sample of it. Really, everyone is mostly excited. Obviously, there is some fear and concerns, and that's supernatural.
Yeah. Okay. We continue. Who believes robots will take more jobs than they create? Hands up. Or not? Okay, some, yeah. I see around, no, maybe half of it. And who believes the opposite? That's more. What do you believe?
We have to put your time frame on it to actually answer this question. Right? So if you say until 2030 or something, like there is, it will basically fill the gaps which are going to exist. I mean, if you're talking about Europe, China, Japan, we will have 100 million less human labor by 2030. So we somehow have to find a solution for that. And then afterwards, one day, there will be a tipping point where simply humans will do other stuff than doing the physical task.
What do you think, Bella? Do you think that, what about the labor shortage? Will they take away human jobs with robots? Isabella?
I think about it. You can first.
Yeah, I can go. I think that as we think about, I think healthcare and hospitals is actually a really great example of a workforce that currently is very much short the human labor to do the work.
Yeah.
And adding automation, adding robots forces the organization to do a workforce redesign. So you really have to think about what do we actually want people doing versus robots doing.
Yeah.
And I think we'll start to see that happen across every industry, but it does require a change management in order for it not to be just a bunch of displaced jobs.
Yeah. Yeah. What
So physical AI is really just a flavor of AI, but it's manifesting itself in the 3D world or in the physical world that we live in. We have examples of AI displacing people. There are a lot of layoffs in major companies. So that's the first indication that automation, when met with AI, could potentially displace a lot of people. It doesn't mean it cannot create a lot of jobs elsewhere or leave room for more creative tasks that humans are perfect for.
Well,
so-
yeah, I
Right.
think so too. I mean, maybe I should not have an opinion as a moderator, but
Should actually.
but yeah, I think the computer also accelerated human potential, and so AI will. And Jensen Huang from NVIDIA once said that a growing company, and I think AI is growing companies, will need more people. Jobs will shift. Maybe they will change. Yeah, but I think it's also interesting what you said, David, that you need to put it on a time frame. So maybe one question to add there, like you said, some things will change to, what will change to 2040?
Yeah, I think there will be a lot of human replaced in that spaces of let's say physical work, but I think it will be more massive to be a human again. So because we will get annoyed by these technologies and we will just let them. But I think it's also a little bit, because I hear that once also for households, and I get a lot of critiques actually from, let's say, some parents, which I said, hey, you will not have the issues with your children anymore in the future, so you have to think about just things which you enjoy, like playing with them, but not about who's going to clean the room afterwards, and I get a lot of critiques. But I think it's a little bit similar to like 100 years ago, maybe 150 years ago. There was also a lot of critiques about people which don't know how to bring the milk out of the cow, because you don't deserve to drink milk if you don't know how to do that. And I think this will be the future. We'll simply get used to that everything gets solved by robots around us, and we will transform ourselves more into a different, let's say, how to say it, we will use our time differently. That's the thing I want to say.
Yeah, probably. Let's continue. Or you want to add something?
In 2030, technology becomes invisible. Robots are everywhere, but you don't notice them. They are cooking, driving, carving. Human can focus on love and creation. Robots focus on work and action. It is a beautiful world.
Yeah. So, dear audience, who would feel comfortable with a robot working in the hospital or caring for a relative? Better than there is no one, huh? And who would not? Oh, okay. Andrea, you want to say something to that?
No, I mean, it's great. I love that everyone is happy to see robots in hospitals. I do think the longer term vision of that is robots as a caretaker, and I think joining caretaking teams, I think, is the way to think about it.
Let's stop here because we're running out of time a little. Who would trust a robot to make decisions in unpredictable situations? And who would not? What do you say to that? David?
I think it depends also a little bit about the situation itself. I think, I think today maybe not so much. I think you're right. I saw already a lot of crazy things.
Yeah.
But I think in the future, like it's more predictable, and we have to find ways to have it more predictable. I think also here, the good thing about robots is they don't, let's say, they don't get angry, they don't feel it's Monday or Friday or whatever. So they basically do all the time consequent good work if they're good trained. And I think we can trust them a little bit more than maybe some humans which just have to leave now, maybe the hospital because they have dinner or a date, and they just don't care as much as a robot would because the robot don't have a dates yet.
Yeah. Anything to add? That maybe one more word to it. Yeah, Andrea?
I mean, I was just going to add that I think I think there's a lot of things to think about in terms of the complexity of the decision. And but I think autonomous vehicles are a great parallel. So there was a while that you're like, I don't know if I trust what my Tesla's doing here. I'm taking over. But then there becomes a point which you trust that the robot or the car has seen enough of unpredictable situations that you trust it. So I think we'll see a similar kind of progression with experience.
Okay. We all know we are almost there, but not quite. So if you could take away one barrier, just one, what would that be? If you have the magic to do so, what is the one barrier you would like to take away? Who wants to start? Or is there any barrier?
Just improved AI, because that's really what does everything, honestly. So if we can magically somehow have unsupervised AI imitates the entire environment that we are living in as humans, I think that would be that's, in my opinion, the biggest barrier.
Okay, let the magic happen.
I'll say, I think the technology around force sensing and everything that's needed for more dexterous manipulation, I don't think we know exactly what the right form factor and sensor package is. So if I could wave a wand and we've solved that problem, that'd be cool.
Isabella? Yeah?
I think about it.
Okay. David?
I think the biggest barrier we'll face as the next challenge will be the communication and interaction with the physical world and also the device built around us, because I think this is not smart to build just a smart humanoid robot, because it shouldn't go to open the oven and things like that. It should just know what's inside when it's ready, because it's a different possibilities of communication protocols. And here it's also what we try to put a lot of effort in. It's like, how do you interact with actually the future physical AI world, which is made for that, and also encourage, let's say, all the companies around